All right, so I'm going to start from the first question, even though we did it in class. Okay, so there are 14 girls and 21 boys, and we want to make teams. So we want to know what the greatest number of teams that can be made if there are 14 girls and 21 boys. So again, so one of the clues that you can say definitely is that the greatest, right? So that tells us it's a GCF problem. So let's do that. Right, 14, 21. Sorry, put a comma there. You can use 7. 7 goes to 14 2 times. 7 goes to 21 3 times. Let me write boys here and girls. Or is it the other way around? It's the other way around. I'm going to write girls and boys. All right, so this is a GCF, so there is no other number that goes into 2 and 3, so we stop. So what we can do now is circle. We're going to circle just this because it's a GCF, right? So GCF is 7. So what I want you to do is write 7, and I want you to write an answer. So the greatest number of teams is 7. Each team will have 2 girls and 3 boys. Okay, and that's what I was looking for. Okay, so let's work on the next one. So the next one says there are 100 students lined up. Okay, imagine there's a long line of students, and we're going to give out prizes. Let me just list some numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, what is it? 11, 12, 13, 14, 15, 16, 17, 18. I'm just going to list a few, right? 4, 25, 26. I'm going to stop there. So I know that every kid, every sixth child gets a pencil. So this guy's going to get a pencil. This guy's going to get a pencil. That guy's going to get a pencil. 24 is going to get a pencil. And then 30, and then 36, and so on and so on. I just wanted to show you. So I'm going to write circle, red circle is a pencil. And then with green, every 9th student is going to get a notebook. So kid number 9 gets a notebook. Kid number 18 gets a notebook. Kid number 27 would get a notebook. Right, so let me write 27 over here. Oh, and on the red, I'm sorry, I apologize. For the pencil, I forgot 18. So notice that 18 has 2 circles. It has a green circle and an 18 green circle and a red circle, which means that kid who is in online, he's on the 18th position, he's going to get a pencil and a notebook. But the question says, how many kids out of 100? So I know the first student to get a pencil and a notebook at the same time is 18. So we know that another 18, so student number 36 would also get a notebook and a pencil. We add 18 to that, we get 54. 18 to that would be 72. 18 to that would be 90. Okay, and if we add 18 to that, we get 108. But 108 is more than the number of students that we have. So if there were 100 students, how many students would get a notebook and a pencil? This guy, this guy, this guy, this guy, this guy. It is an LCM problem. Okay, so if you did the LCM, it would be the LCM of 6 and 9. So the number would be 3. I'm sorry. 3 goes to 6 2 times. 3 goes to 9 3 times. Remember the LCM is this number right here. We make a circle around those. So the LCM is 3 times 2 times 3. 3 times 2 is 6. 6 times 3 is 18. Notice that we get the same answer. So the smallest number, right? The first student to get those would be 18. So, and that tells us that every 18 students would also get a pencil and a notebook. Okay. So again, we've done these problems in class, but I'm just repeating it. So at the carnival, we know that it's 1 p.m. right now. And we know that there are 2 brothers in there. Okay, and they agreed that they will meet back at the Ferris wheel from time to time to see whether the other is ready to leave. So Ralph checks every 15 minutes and Joe checks every 24 minutes. what time will they meet at the Ferris wheel again? So again, this is something that repeats. Somebody's checking every 15 minutes. The other person's checking every 24 minutes. Okay, so definitely an LCM problem. So we can use 3, 5, 3 into 24 is 8. We can't go anymore, so LCM is 3 times 5 times 8, which is equals to 120. But let me just make this clear that this is 120 minutes. So if it's 1 o'clock right now, right, and we add 120 minutes, what time would it be? Well, 120 minutes, we know that 60 minutes is 1 hour, right? So it's double that, which is 120 minutes, which means that it's 2 hours. So 120 minutes is the same as 2 hours. So if it's 1 o'clock right now and 2 hours go by, plus 2 hours, we get a time of 3 p.m. Okay. 4, we want to make flower arrangements. Okay, so we have here a vase, and we want to use some red flowers. What do they have? Some red flowers, some white flowers, right? And we want to use some pink flowers, right? So we want to make this lots of bouquets, and they each should have the same amount of red, same amount of white, and same amount of pink. So how many bouquets can we make, or how many arrangements can we make is the question. Okay, so what do we have? We have 36 red, I'm going to write red on top. We have 60 white carnations, and we have 72 pink carnations. So how many flower arrangements can we make so that each arrangement has the same amount of each? I think we use a number 6 in class, right? Well, let's use 6. 6 go to 36. So wait, sorry, is this a GCF or LCM? This is a GCF problem. You can tell it says what is the greatest number. It's a GCF problem. So 6 going to 36 6 times, 6 going to 60 10 times, and 6 going to 72 12 times. Can we go on for all 3 numbers? Yeah, we can. We can use 2. 2 goes into 6 3, 2 goes into 10 5, and 2 goes into 12 6. This is a GCF, so there is no number that goes into all 3. Okay, 3 goes into 3, 3 goes into 3, and 3 goes 6, but it doesn't go to 5, so we can't use it. So we are done. So GCF is 12 arrangements. Now for GCF, this works nicely, and each one's going to have, each arrangement will have each arrangement will have 3 red, 5 white, and 6 pink. Okay, every arrangement is going to have this many flowers. Okay, so I'm glad we're doing this because number 5 gave me a little problem. So let's do number 5. So number 5 says, here you go to the supermarket, and juice, there's 6 juices here. 1, 2, 3, 4, 5, 6. That's a juice. And then granola bars comes in 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, there are 24 people on the team, and we want to buy 1 juice and 1 granola bar for everybody. Okay, so if I go to the supermarket, or I ask you to, hey, go to the supermarket and buy enough for everybody so that everybody has 1 juice and 1 bar, how many packages of juices and how many packages of bar do we have to buy? Okay, so so here it says what's the least number, right? You don't want any leftover, right? You don't want to buy too much, so you want to buy exactly. So the least, so this is an LCM problem. So I'm going to use 6, I'm going to use 8. And then, what number can we use? We can use a number 2, 3, and 4, right? So now, we circle this, and LCM is 24. So that tells me that I need to buy 24 juices. That makes sense, right? And 24 bars. That also makes sense. Now, what we can do, and the easiest way to do this, if I need to buy 24 juices, I can go 24 juices, and I divide by 6, right? Which means I need to buy 4 packages of juice. For the bars, I have 24 that I need, divided by the 8, right? Because there are 8 bars in each package. That means I need to buy 3 packages of bars. Okay, so the smallest number that I need is 24, and it's easiest if we divide 24 by how many are inside the packages. Okay, and now pay attention. Don't do this. Okay, don't pay attention to this number 3 and the number 4, because this is juice, and this is what you call granola. All right, and you don't need 4 boxes of granola. You don't need 3 boxes of juice. So don't look at the bottom, but instead I think it's easier if you take the number, the LCM, and divide it by the number of juice and the number of bars. Okay, that's probably easiest. So that's 4. Number 5. Okay, no, number 6. Now we have 12 jars of grape, 16 of strawberry, and 24 of raspberry. What we want to do with this? We want to put them in boxes, right? So each box have the same number of jams, right? So we want to put them in boxes. What is the greatest number of boxes that we can make? So again, this is a GCF problem. You know, we can highlight. Okay, so I can't highlight here, guys, because I have to go back and forth. So greatest you would highlight. You can highlight 24, 36. Sorry, 12, the 16, the 24. So being that's a GCF problem, with GCF everything works out nicely. So let me write 12, 16, 24, and on top of that I'm going to write grape, strawberry. The last one is raspberry. Okay, let's pick a number. 2, yes. Can we go higher? 3, yes. Can we go 4? Yeah, we can go 4. 4 goes in 12 3 times. 4 goes to 16 4 times. And 4 goes to 24 6 times. Can we go again? No, not for all 3. So I'm done. So what does that mean? It means that I can make 4 boxes. Right? I can make 4 boxes. 1, 2, 3, 4. Each box it's going to have 3 grape, 4 strawberry, and 6 raspberry. And we're going to repeat the same things. 3 grape, and I'm just going to write the initial. 4 strawberry, 6 raspberry. 3 grape, 4 strawberry, 6 raspberry. 3 grape, 4 strawberry, 6 raspberry. And that's going to be, okay? So with GCF, these numbers work out really nice. Okay. What's the next question? So, sorry. Next question is the shampoo. So you have 24 bottles of shampoo, 36 of hand lotion, and 60 bars of soap. And we want to make gift baskets, right? So we want to make gift baskets so that each gift basket has the same amount. So if you're giving it to your friends, every friend gets the same amount. So you have 24, just call it shampoo, 36 lotion, hand lotion, and 60 bars of soap. So you want to, what's the greatest number of boxes that we can make? So it's a GCF problem. 24, 36, 60. 2 works, 3 works. Let's go higher, guys. 4, 5, 6. 6 works. We can even go higher. Okay, hopefully some of you said only some of you said 12, and I don't know why I'm doing this. Sorry. It's backwards. 24, 36, and 60. We're going to use 12. 12 goes 24 2 times. 12 goes 36 3 times. And 12 goes 60 5 times. Okay, I keep forgetting. So I'm going to write shampoo. I want to make a habit of it. Lotion and soap, so I know what we're talking about. So the GCF is only this number here on the side. So GCF is 12. Right, so if you use other numbers like a 2, a 3, or 4, you're going to multiply and you're going to get 12. So the GCF is 12. So I can make 12 boxes. Each box is going to have 2 shampoo, 3 lotions, and 5 soaps. Okay? That was an easy question. Next is 2 faucets are dripping. Okay, you have a faucet of water. Okay, so I don't know if I can draw a faucet. I don't know how to draw that. Okay, maybe like that, right? Faucet of water, and it's dripping water. Water. Okay, and that's dripping water. Right, the water is coming out. Right, it's dripping. One is dripping every 4 seconds, and the other one is dripping every 9 seconds. So this is the same thing as the clapping one, right? Where our mirror and someone were clapping. So how many seconds will it be before you see the same? So you have another faucet here. I'll draw again. You have another faucet, okay? Okay, you have another faucet, and water is dripping again here too, right? So this one is every 4 seconds, and this one is every 9 seconds. So at some point, they will drop water at the same time. When will that be? Okay, so same time. So here, one of the clues is the word same time. When in the future, how many seconds will they drop water at the same time? So this is definitely a LCM problem. So can you think of a number that goes into 4 and 9? No? Then it's just going to be 4 and 9. So the only number, so the LCM is the product of all those numbers. And the answer is 36 for 36 seconds. At second 36, both faucets will drip together. In terms of science, make one inference as to why water is dripping. I don't know, maybe because we didn't close it together, close it tightly. That's a good question. I don't know. Most of the time in my house is because we didn't close it tightly enough. 12. Mr. Stevenson's ordering shirts and hats. There are 16 scouts, so there's 16 kids, okay, 16 students. All right. Hats comes in packages of 3. There's 3 hats in here. And what's the other one? And shirts come in packages of 5. Okay, shirt, 2, 3, 4, 5. So I want to buy just enough for the 60 kids. I don't want to buy more hats than I need to. And I don't want to buy more shirts than I need to. I just want to buy enough so that everybody gets 1 hat and 1 shirt. So, okay, what's the smallest number that I need to buy? So LCM is the LCM of 3 and 5. Okay. So the LCM give me a second, guys. I'm missing something. Six. Oh, I want to buy it for 60. Okay. So instead of doing the LCM, I'm going to do it a shorter way. Okay, we can just do it sorry, instead of using the a ladder method, we can just do it a shorter way. So we have 60 kids, and if I divide it by 3, I need 20 packages of hats, right? 20, what is it? Boxes, 20 packs. 20 packs of hats, right? If I have 6 shirts in a box, in a package, so I divide this by 6, it means that I need 10 packs of hats. Okay, so that was kind of silly. So not all the time you need to do the LCM. Okay. It was, wait, how many? And shirts comes in packs of 5. My apologies, guys. I know there's something wrong here. Comes in packs of 5. So 60 divided by 10. I need 12 packs of hats. Okay, my apologies. So it is 1, 2, 3, 4, 5. I know why I keep saying 6. All right. Ten. There was Thompson class was competing field day. There are 16 boys and 12 girls. He divided the class into the greatest number of teams possible. Let's name the same number of boys and girls in each team. So how many girls and boys from each team, and how many teams total can we make? Well, what's the greatest number? That tells us that it's a GCF problem. Let's divide this by 4. 16 is the number of boys. Sorry. 12 is the number of girls. So it's 4 boys. 4 times 4 is 16, and then 4 times 3 is 12. Can we continue? No, we can't. So there's our answer. So GCF is 4. And how many boys and girls per team? So each team will have 4 boys. 4 boys, sorry. 4 boys and 3 girls. All right, so that was easy. Josie has 15 quarters, 30 dimes, 48 nickels. He wants to group the money so that each group has the same number of each coin. What is the greatest number of each coin? What's the greatest number of groups we can make, first of all, and then how many coins of each will be in each group? We have 15 quarters, and I'm going to write Q for quarters, D for dimes, and 48 nickels. And you want to separate it into groups. So can we pick a number? 5 now, 3. 3 goes to 15 5 times. 3 goes into 30 10 times. 3 goes to 48 16 times. Can we go on? No, because this is a GCF problem, so we stop here. So GCF is 3. So the GCF 3 means the greatest number of groups is 3. Each group will have 5 quarters, 10 dimes, and 3 nickels. Okay. And then finally, last question. 2 students are stacking blocks one on top of each other. Reese's blocks are 6 centimeters high and Maddie's are 16 centimeters high. How tall will their stacks be when they are at the same height for the first time? So they're stacking books, right? So this guy is going 6 centimeters, then 6 centimeters, and another 6 books, 6 centimeters, another 6 books, 6 centimeters. The other kid is doing 16 centimeters, and then 16 centimeters, and then on top 16 more centimeters, and etc. Right? So when will they be at the same height for the first time? Okay, so this is definitely an LCM problem, right? Because something that's repeating over and over. So 6 and 16. Number 2. 2 goes into 16 3 times. 2 goes into 8 2 times 16, 8 times. So can we continue? No. The LCM is 2 times 3 times 8, which is 48. So when they are at 48, the 48 centimeters, okay, 48 centimeters, they'll be the same height. They will be at the same height at 48 centimeters for the first time, right? And then if they keep continuing, they're going to be at the same time again after 48 more centimeters. Again after more 48, but they're not asking how many times or the other heights. They're just asking the first height. When will they be together? They will be together. It's the first time when both stacks are at 48 centimeters. So the question now, although they didn't ask, I'm going to ask you. So at 48 centimeters, how many blocks is a 6 do we use? So 48 divided by 6, we used 8 blocks, right? So one kid's going to use 8 blocks to get to 48. And the other kid, 48 divided by 16, right? Because he's using bigger blocks, right? His blocks are bigger. How many blocks does he need? He's going to need 3 blocks. Okay? And it seems like that's that. Although I do want to, revisit one question that is bothering me a little bit. And I think everybody knows it's the, not 5. T-shirt number 9. Okay, something throwing me a little. Okay, so if you want to stop, you can. So I'm just going to redo number 9. So we have 16 kids, and each kid, 16 scouts, right? So hats, there's 3 in each. And then shirts comes in packages of 5. 3, 4, 5. So again, this is an LCM. And the LCM between 3 and 5 is the least common multiple, right? So if you look at their times table, there's nothing, it's 1, and then we multiply. So the LCM is 15. Now, what does that mean in terms of okay, so if you think of in terms of LCM, that's not going to work. That's not going to work in this problem. Okay, and not. Let me take that back. If you do it in this way, I think it's going to just complicate it for you. I still think that the easiest way to do this, you have 60 kids. If you want to talk about hats, there's 3 hats in a bag. So you divide that by 3. How many bags do you need? You need 15. Here you have 60 kids. There's 5 t-shirts in the bag, so you divide this by 5. 6 divided by 12, and that's how many bags you need. How many bags of t-shirts you need to, so that every kid has the same amount. Okay, so hopefully I didn't make a mess out of this.